And I have researched land-based runoff and the effects on the Great Barrier Reef coral. Apart from being a wonderful tourist destination, the Great Barrier Reef is the world's largest coral reef ecosystem. 3,000 individual coral reefs. It has been reported that nutrient and sediment levels in the Great Barrier Reef catchment are 5 times higher than pre-European settlement levels. In order to do my research, I had to establish credible sources. This was my priority. Using the curtain LibGuides, I determined criteria for identifying credible sources. I also established a series of keywords based on my inquiry questions to provide appropriate information. I utilized Google Scholar and URLs such as .gov and .edu. I continued to check my research information was relevant and credible against my criteria, and I looked for references cited within the information. I also approached government institutes to see where they obtain their data. Accessing the data from the government institutes posed some challenges. Some required registration, and other reports were beyond my level of understanding and interpretation. The databases were large, and without constantly revising keywords, it was overwhelming to determine which were most relevant to answer the inquiry questions. It was difficult to stay focused on my specific task, as there are so many threats and impacts to our reef. In 2002, the Great Barrier Reef had lost half of its coral cover in the past 27 years. There are two main corals, hard and soft. The hard coral was the reef-forming coral. It relies on light and the consumption of algae to form. This hard coral is home to a multitude of marine life, including some rare species. The coral reef provides shelter and food to these marine animals, important for their successful survival. In the late 19th century, beef cattle grazing and sugarcane cultivation have been dominant industries in the Great Barrier Reef catchment. Always being nutrients and sediments detected and monitored from land-based runoff. However, in recent decades, there have been detections of herbicides and pesticides entering the reef. These are linked directly to these dominant agricultural practices. The increased use of herbicides and pesticides, combined with the formation of river water plumes following the wet season rains, resulted in these new chemicals entering the Great Barrier Reef. There have been programs put in place to research and protect and prevent water quality entering the catchments in the past and present. Water quality affects the resilience of the reef systems. Higher concentrates of pollutants such as sediments, nitrogen, phosphorus found in fresh water flow entering the reef can be identified by poor water clarity or higher detection of chlorophyll levels. Higher concentrations of these pollutants reduce the opportunities for hard corals to establish. Poor water quality affects coral as it contributes to other threats, weakening the coral's resilience. The largest clear threat from land-based runoff was that it contains fine sediments that reduce the light needed by corals. Pesticides and herbicides in land-based runoff also provide nitrogen discharge that accelerates and encourages algae growth associated with outbreaks of crown and thorn starfish, which eat coral. Land-based runoff doesn't directly affect the Great Barrier Reef coral. However, it does affect the water quality that contributes to effects on the health and survival of the coral. It appears existing strategies to manage land-based runoff entering the catchment had not met intended results. Evidence suggested that restoring land flows into the catchment to manage new flood plumes, research into different agricultural product use, and reviewing current land use could help to control water quality in the Great Barrier Reef. Research and findings suggest that consistent water quality will enable the coral to become more resilient. Inquiry on environment sustainable practices would best suit year levels 5 to 6. I have achieved many of the criteria through my inquiry: the growth and survival of living things affected by physical conditions of their environment, Science involves testing predictions by gathering data and using evidence to develop explanations and evidence. Scientific knowledge is used to solve problems and inform personal community decisions, and compare data with predictions and uses evidence in developing explanations.